Hello and welcome to lesson 4C. I can use inequalities to describe the relationships between sides and angles within one triangle using the triangle inequality theorem and between two triangles using the Hinge theorem and its converse. So we did a construction back in Unit 2 where you tried to construct a triangle, and when you did it, you realized that you were unable to construct the triangle because two of your sides were so short that as you did the construction, you couldn't actually get them to meet. Well, that's actually a great visualization of the triangle inequality theorem. And the triangle inequality theorem states that the sum of any two segments in a triangle must be greater than the length of the third segment. So usually we take it with the two shorter sides. The sum of the two shorter sides must be greater than the length of the third side. So looking at this diagram down here, we are actually unable to make a triangle in this picture. And you can see how if we had a compass and we were doing our arcs, these guys they wouldn't meet and we would not be able to form a triangle. Well, that's because if DF is 2.01 and EG is 2.00, adding those together is less than 4.47. Because this isn't a greater than relationship, we cannot form a triangle. So that's basically the triangle inequality theorem. Similarly, whenever you're missing the side of a triangle or you don't know what kind of range your triangle has, the third angle of a triangle is always bound between the absolute value of the difference of your two sides and the sum of your two sides. Okay, so if X is a missing side length in your triangle, it's bound between the difference in your two sides and the sum of your two sides. So for example, if I knew that I had a triangle with side lengths 4 and 7, and I wanted to know the third side, well, there's a range of possible values. It can be between 7 minus 4 is less than X is less than 7 plus 4, or 3 is less than X is less than 11. That third side is between 3 and 11. Okay? The Hinge theorem actually compares two triangles, and it states that if you have two sides of a triangle such that they are congruent to each other between the two triangles, notice we've got tick marks, right? This looks a little bit like SAS, but notice the angles are not the same. The smaller hinge angle is across from the shorter side, and the longer hinge angle is across from the longer side. And actually, there's a great visualization of this. If you go to this link here, and actually I've got it pulled up on our video here, you can see it in action. So what it basically states that if you've got two sides that are the same length, as you widen your hinge angle, that side length AB, think of it as the rubber band, it gets larger. So the larger the angle, the longer the side. The smaller the angle, the smaller the side. Okay? And let's keep going with that. So for example here, with two triangles, I've got AB is congruent to GI and AC is congruent to GH. Notice you have to be given that those sides are congruent. I can draw a conclusion where measure of angle A is greater than measure of angle J. Clearly A is obtuse, J is acute. That means that their opposite parts are going to have a relationship. BC must be greater than IH. In other words, if a hinge opens wider, its opposite side is actually longer. Okay? And the reverse holds true. If I know that the opposite side is larger, then the angle is wider. Okay? So let's take a look at a couple of examples of this. Here, I want to draw a conclusion based on the Hinge theorem or its converse. Looking at this, I need to always look for my SAS pattern. I need two sides that are congruent. Well, here, the 10 is congruent to the 10, and there's a shared side, so the angles in question are up here. Now, they're not actually congruent, so I'm not going to mark them as congruent, but I want you to recognize that those are the two angles we're dealing with. Well, the 30 is across from a 6, and the 25 degrees is apart from GH. Well, because 30 is larger than 25, then FG must be bigger than GH, and I know FG is 6, so 6 must be greater than GH. Now let's look at this guy over here. Here again, I have to find kind of an SAS pattern. Well, I've got an 8 and I've got a 10. So, and the included angles here are angle P, which is across from 5, and angle T, which is across from 5.1. Well, 5 is less than 5.1, so the measure of angle P must be less than the measure of angle T. And that's all you got to do for Hinge theorem. If y'all have any questions, please ask us. Otherwise, that's the end of the lesson and the end of Unit 4. So thank you guys very much.